really champing at the bit to show their latest technologies.
The next wave of technology.
The show has bounced back with a vengeance.
Hi, I'm Adrian Eichsfeld. I'm with the Bionic Learning Network, and this year at the Hannover Fair we are presenting the BionicCellFactory, a highly sophisticated piece of hardware I'm standing in front of. It uses all sorts of sophisticated means and hardware in order to bind carbon dioxide from the atmosphere, process it, fix it inside of algae, which are then furthermore processed. I will now give you an in-depth view of all the modules and how they're working. Now we're standing in front of the very first module of the BionicCellFactory. It's the CO2 Collection module that uses the resin, as shown up here, to bind carbon dioxide from the atmosphere. We got 0.04% in the composition, and we use this inside of this reactor to continuously bind it. So we flush air past the resin, binding the carbon dioxide until this resin is saturated. So eventually, once it's saturated, the nice property of this material is that once we heat it up, it will release all the carbon dioxide. So what we do by compressing the air and moving it past the sample, we put a vacuum in the silver tank. Once we're done with flushing air past the resin and it's saturated with carbon dioxide, we then close everything off, connect this reactor with the tank, which is now filled with vacuum, and heat up the resin. This will instantly release the carbon dioxide, which will then be sucked into the tank. Now, the question is obviously, how high is the concentration that we can manage in this module? We eventually get to a value of 4%. That doesn't sound too much, but let's be honest, we are already increasing from 0.04 to 4%, which is a 100-fold increase. Now, what are we going to do there with this carbon dioxide? Now that we caught it, we will transfer it to the algae reactor. We are now standing in front of the second module. That's the algae liner. It's an algae bioreactor. So as you can see, there are two tanks. Some people might ask, why are there two tanks if you only need one to aerate it with carbon dioxide? As a matter of fact, algae, similar to plants, will produce oxygen while eating carbon dioxide. So our problem is, because of limited solubility of all oxygen, eventually it will saturate this liquid and the cells aren't able to get rid of the oxygen anymore. So in order to get this out of the liquid, we flush air through it and blow it into the room. This way we can continue this process indefinitely. So now that we got all the oxygen out of the way, we have our 4% carbon dioxide. Obviously, we now want to have a use for it. In the second tank, we see at the very back of this exhibit, we will now bubble in and insert the carbon dioxide. Now, the benefit of this is why we all know that using a CO2 sparger, we can aerate bottles and have sparkling drinks. We have a limited solubility of carbon dioxide at ambient pressure. In this particular case, a lot of carbon dioxide would be lost if we couldn't circulate it. So we see in the second module, in the control module, we got a compressor that will take the carbon dioxide from the top section and recirculate it until it's fully solubilized. This way we don't lose anything of our precious 4% carbon dioxide that we generated at the very beginning. In this particular case, it's actually a benefit that's only this concentration, because otherwise we would have to recirculate far longer and would lose more product. Now we're at the point where we are feeding the algae. In a similar fashion of us not being able to survive on an only meat or only salad diet, algae don't only need carbon dioxide to grow. In a similar fashion as we need vitamins, we got the second module. You see those two bottles, they contain trace elements similar to vitamins that are then added to the algae. Now, statistically speaking, everything will be perfectly fine. They got ample of carbon dioxide to grow and trace elements to survive. However, as we all know, it's not always science and everything works perfectly fine. So in order to monitor that everything is working perfect, we're going to the analysis model. We are standing in front of the analysis model. On the one hand side, we got the quant, which is like a sophisticated laser array, where you use a laser to shoot it through the cell and see, depending on what emissions we have, whether this might be a healthy cell or an unhealthy cell. The thing is, as per usual, we got a nice statistics, however, seeing is believing. In this particular case, we fancy the microscope, which is in turn connected to a camera, which is then run through a computer with two 4070 RTX graphics cards and using TensorFlow as AI to assess the picture in real time. So what we are seeing here is the real-time picture of the algae as they pass the camera. Depending on the outcome of TensorFlow versus Python-based, we see the circularity, how green they are, how healthy they are, and can use sophisticated means to assess the overall cell health faster and more precise than we could do with other means. also in a very visible way. Now that we obviously are fine with growing algae, they're healthy, they're growing well, what are we going to do with them? So first, we got the harvest module. We're using a centrifuge to collect the algae and separate them from the medium. We're spinning up the centrifuge, the cells with sediment on the top rim of the rotor, and once we break it, only the liquid will fall back to the bottom. There are holes in it, and this way we subtract the liquid, the medium that are still full of nutrients that will then be recirculated in the reactor. Once we've done this, we will spin up the rotor again and use a scraper to get all the algae off. This will then be transferred to this second vial. As we can see on the left-hand side, these are the algae from the reactor that are light green, and here on the right-hand side we see the already concentrated algae after being centrifuged. This way we are able to continuously separate the algae from the bioreactor. Now we do have biomass. We could already use this for food stock or in the dried form as seen in this particular flask as a nutrient or as some sort of superfood rich in amino acids and oil and other stuff. In this particular case, we push it even further. With the enzymatic transformation module, we're using this harvested material, which gets transferred to a 5-reactor system to further evolve on our product. In the first reactor, we're using enzymes to open up the cells. Now that we opened up the cells with enzymes, we're transferring it to the second reactor. Here, we use another enzyme to open up the organelles that we release in the first step. Knowing that the cells contain 10% oil, we are releasing oil at this stage. You can't see anything yet because those are really tiny droplets. We pump it in a third reactor, which is static and isn't being shaken, and wait. After a certain period of time, eventually the oil, which is lighter than the remaining liquid, will separate. We see a top phase, which contains oil, algae oil, which can already be used as a product, and the bottom section of harvested open cell that can be used to feed livestock. Amino acids and other precious materials are contained, which would then, as said, be a valuable food stock. Now in the next step, we want to separate those two liquids. So in order to perform the separation, we pump it through an array of 3 sensors that can differentiate between air, oil, and the opened algae. Eventually, once we pass it through it, we remove the algae to the bottom of the setup to further use it in other applications until we got everything emptied and detect oil. This oil is then transferred to the fourth reactor. In this fourth reactor we add another enzyme. As we can see here, 2 other phases form. This happens because an oil, when exposed to lipase, is split into glycerol on one hand side and 3 fatty acids on the other side, which can already be considered as an e-fuel or as a propellant or as an energy carrier. Now, as we can see here, it's not yet cleanly separated, it's milky liquid, so we give it another rest. We put it to the 5th and final reactor. Here we are just waiting until it separates on its own, as we can see here. And later on we use the same method as before to separate the glycerol from the e-fuel. This way we can use algae as fixating carbon dioxide from the atmosphere, produce biomass, to harvest it and then transform it to a precious valuable material. Depending on which enzymes we use or what kind of cells we use, we can have higher yields, produce more biomass or different components. And this was everything I can tell you about the BionicCellFactory.